Hello there, this is the 22nd video going over all the documentation made by Apple for VisionOS. Let's learn everything we can possibly learn and take a look at this article. Diagnosing issues in the appearance of a running app. Inspect your running app to investigate issues in the appearance and placement of the content it displays. At times, your app content may appear to be missing, out of place, or have an appearance that is incorrect. To identify and diagnose the cause of these issues, attach the debugger, reproduce the error, and then narrow down its root cause by inspecting changes in your interface, the code that is executing, and the states of variables. If you configure a schema's run action for debugging by using the debug execution checkbox in info settings, the app will attach to the debugger automatically when the app uses the schema. To attach the debugger to a process that is already running, choose debugger attached to process and select your app process from the list. If you haven't seen this, it's in the previous video. Temporarily override system settings to control your app's appearance and reveal problems that only occur when these settings are in effect. Understand layout issues by visualizing your views in the stacked layers and debug content in immersive spaces by adding visual overlays. Adjust system configurations to identify their impact on your views. Some visual issues only arise when you configure the system using specific environmental settings. Xcode provides environmental overrides when targeting iOS, macOS, and tvOS apps to help you debug these issues. Use these environmental overrides to change the interface style, dynamic text size, and to induce the effect of other accessibility options, so you can understand the effect of these changes on layout and visual appearance of your views. To enable one or more of these overrides, click the Enable Override button on the Xcode debugging toolbar, toggle the switch next to the override category, and configure the controls under the category heading. Let's take a look at these environmental overrides. We have Appearance. View your app's content with a light or dark appearance. Select between light or dark and dark appearance using the radio button. Dynamic type. View your app's content using different dynamic type sizes. Select the size using a slider. For more information on dynamic types, see dynamic type sizes. Accessibility. View the effects various accessibility features here have on your app's content. Click the checkbox to enable or disable accessibility features. Now, let's take a look at this. All right, we have a starter app here. This is when you just open and create a project. Here we see the debugging tool, environmental overrides. Select the appearance for a different appearance, light or dark. Go to dynamic type to enlarge or shrink the text based on the settings given. And lastly, we have accessibility, improve contrast, reduce transparency, bold text, reduce motion. We can't see those. On and off labels, button shapes. We have grayscale and smart invert and differentiate without colors. We have a bunch of cool things going on. And those are the environmental override options. Next, let's resolve issues in the layout of your UI kit and SwiftUI views. Use the View Debugger, available when targeting iOS, macOS, tvOS, and watchOS apps, to diagnose the reasons an item in your user interface is in the wrong position or is the wrong size. Set a breakpoints in your app after it presents the view. For example, in a view did appear method, then click the View Debugger button in the debugger bar when the debugger pauses on your breakpoint. Alternatively, just click the View Debugger button after your app presents the view. The debugger displays a 3D rendering of the current view on the canvas in the center, with a representation of the view hierarchy in the debug navigator. Drag the view in any direction to see a 3D representation of the current view stack, and use the controls at the bottom of the canvas to adjust the views and space between them. Click to select a view in either the visual rendering or view hierarchy in the debug navigator. Then inspect details in the Object Inspector or Size Inspector. Resolve your layout issues according to the types of layout. Frame-based layout. The debugger shows the frame you specify in the size inspector. If the size isn't what you expect, step through your code to diagnose issues with your frame calculations, then fix and retest. This is the size inspector. This way we can take a look at the size of our items. View using auto layout. The size inspector shows constraints. Click a constraint to highlight it in the view debugger. Analyze the constraints that affect the misplaced or missized view to diagnose the issue. Adjust your constraints either in your code or in the interface builder and retest. Views built with SwiftUI. The size inspector shows how SwiftUI resolves the size and placement of your view. With that information, analyze and adjust your SwiftUI code and retest. Okay, let's take a look. Okay, let's take a look at that visual debugger now. This is the visual debugger button. Once you click the visual debugger, you'll be presented with this particular view. With this bar here, we can adjust the spacing between each particular view inside your SwiftUI view. Here's the hello world. Here is the earth for hello world. Here's the frames. Now, next thing we want to take a look at are some of these things here. This removes the background. This has the wireframe and contents. This is light and dark mode. And here are different zooms that we can have when inspecting our view. Now, let's take a look at that size inspector. Here's our size inspector. Here's our particular object. This is current view. This is what we're looking at. Here are our constraints. Here's the size of our view and what we want from it. It has a width of 94 and a height of 20. It is particularly at the spot of 149x and 441y. Here are its bounds inside of its own frame. And this is what we're looking at. And this is a SwiftUI view. Let's take a look at this particular, what we can see in terms of our views, how many views we want to see. Here we have one view, the most upmost front in the foreground, and here we only have the background. At the most background, we have the UI window scene. Next, what we have here is a transition view. Then we have a UI drop shadow view. This is all boilerplate. And then we have our host view controller. Next, we have our little content view, which we have in our code, our starter code. After which, inside our content view, we have our vertical stack. Then, afterwards, we have our vertical stack frame, I believe. And then we have our content inside our vertical stack, our image, and our text. And lastly, once we get to the most foreground, we have the content itself, the CG draw view that draws this particular item with our UI hit test view and the CG draw view for our text. All right, with that, let's understand the relationships between objects in an immersive space. For VisionOS apps with content in an immersive space, it is often helpful to see a visual representation of coordinate access, bounding boxes, and other information that is normally invisible. Xcode debugging tools include options to display this information in simulator or on device. Use them to ensure that your entities are located where you expect and interacting with each other and the surroundings the way you anticipate. For example, if an entity isn't responding to events, enable collision shapes to confirm the presence of one, required for error handling and indicate its boundaries. To annotate your content with an overlay, click Enable Visualization button on Xcode debugging toolbar and select one or more of the options. Axis gives you a red, green, and blue arrow indicating X, Y, and Z axis of each object in the space. Use this to understand the orientation of each object. Bounds, green lines that indicate the bounding edge of each entity. Origin, the dot marks the origin of each object. Anchor, anchoring. Red, green, blue arrows indicating X, Y, and Z axis of each anchor point, and the yellow line between entities and their anchors. Use this to understand the placement of entities in relation to other real-world objects in the space. Collision shapes. A white outline around the collision shape of an entity. Use this to understand issues in event detection. Occlusion mesh, a multicolor wireframe around real-world objects in the space. Use this to identify areas where virtual objects are correctly or incorrectly being hidden behind real objects. Surfaces, white border lines and diagonal markers marking each surface. Use this to understand the borders of surfaces. Here we have our app. Let's click this button, Visualizations, and visualize some anchors. There are no anchors. Let's take a look at the axis. Axes are red, green, and blue. Red represents X, green represents Y, and blue represents Z. So X, Y, and Z. Z is pointing towards you. Let's take a look at this in the Earth example. Let's view the globe. Here we have the Earth. It does not have any visualizations. Let's turn it off and turn it back on. Now we have produced visualizations for the Earth. It is getting kind of messy here, so that's not fun. Can we move the Earth somewhere else? No, we can't. Now that this is, I don't think this is the best way of seeing it, but here we are. Let's take a look at the origin. Wow, that's pretty cool. X, Y, and Z. Red, green, and blue. Now, let's take a look at the bounds. Here are some bounds for the Earth, the front, the back, and the side, 360. Lots of great things going on here. Collision shapes and axis. We can interact with this 3D object, so we do have collision in this white outline. Let's take a look at the occlusion mesh. This is where we detect items in the real world. We have a table here, some couches, some of these bookshelves and paintings of that nature. Let's take a look at surfaces. And we have, oh, very cool. We have ceilings, floors, tables. Yes, very cool. Wall. All right. So that's the visualization debugger for VisionOS. And with that, we have come to the end of this article and the end of this video. Next, we'll take a look at another debugging tool, and we will start on our 23rd video. The next video will be on creating a performance plan for your VisionOS app. I'll see you then.